Today we are going to be doing the second section of 3.2, the chain rule. So this is day 2 of the chain rule. Let's look at example 1. Find the derivative of y equals cosine cubed 5x minus sine cubed 2x. So something you need to remember about our function y is that cosine cubed 5x is the same as cosine of 5x all cubed minus sine of 2x all cubed. So when I find my derivative, I have to use the chain rule. And I'm going to end up having to use the chain rule 3 times because I have the outside and then the inside I have to take the derivative twice. So in order to find y prime, it would be 3 times cosine of 5x all squared, because you subtract 1 from the exponent. The derivative of cosine is negative sine, so it'd be negative sine of 5x. And then the derivative of 5x is 5. So that's the derivative of just the first term. Now I have my minus, and I have to take the derivative of the second term. So it'd be 3 times sine of 2x, all squared, times the derivative of the inside, sine of 2x, which would be cosine of 2x, times the derivative of 2x, which would be 2. Then you can go ahead and simplify that. 3 times the negative times 5 would give me negative 15. And I'd have cosine squared 5x times sine of 5x minus negative 3 times 2 would be minus 6 sine squared of 2x times cosine 2x. And that's what it would be simplified. So let's go ahead and look at another example. Example 2, find the derivative of y equals the square root of x plus 1 over x minus 1. So we need to remember that this is the same thing as x plus 1 over x minus 1, all raised to the 1/2 power. Because when taking derivatives, we change those roots to powers. So let's go ahead and find the derivative. So we're going to have to take the derivative of the outside, so we'd have 1/2 times x plus 1 over x minus 1 to the negative 1/2 power. And then we have to use the quotient rule to take the derivative of the inside. So it would be the bottom of that quotient, which would be x minus 1, times the derivative of the top, which would be 1, minus the top of the quotient, which is x plus 1, times the derivative of the bottom, which would be 1, all over the bottom squared. Then we can go ahead and simplify this. And I can get 1/2 times x plus 1 over x minus 1 to the negative 1/2 power. And this would become x minus x, so I'd get 0, and then negative 1 minus 1, so I'd have negative 2 over x minus 1 all squared. And you can go ahead and leave it like that. If you wanted to go through further, we could go ahead and cancel out those 2's and have a negative, so we could actually have negative 1 all over x minus 1 squared times x plus 1 over x minus 1 to the negative 1/2. And we can just stop there. So I want you to look at this quick quiz. So which of the following gives the derivative of y with respect to x for y equals sine to the 4th of 3x? And we do not want you to use a calculator. So go ahead, take a moment, and try to determine which one of these is the best answer. Hopefully going through, you chose B. B is the correct answer. Slopes of parameterized curves. So a parameterized curve x of t, y of t, is differentiable if if x and y are differentiable at t. So find in dy dx parametrically, if all three derivatives exist and the derivative of x with respect to t doesn't equal 0, then the derivative of y with respect to x is dy over dt divided by dx over dt. So this is something that you do need to have memorized. So let's go ahead and compute the derivative of the following parametrically defined function. We have x equals 3t minus 1 and y equals 5t squared. Something that we'll need for both of these is we'll need to solve for t. And looking at these, it's a lot easier to solve for t in x. So to solve for t, I would end up having t equals x plus 1 divided by 3, I believe. So if I want to find dy over dx, that would just be dy over dt divided by dx over dt. So dy over dt, if I look at 5t squared, the derivative of that would be 10t divided by dx dt, the derivative of 3t minus 1 is just 3. But we want it in terms of x. Right now it's in terms of t. So we would need to plug back in what t equals, and t equals x plus 1 over 3. So this would be 10 times x plus 1 over 3, all divided by 3, which would then simplify to 10 times x plus 1 all over 9. And let's just change that to a 1. Another way we could do this is we could plug what t equals into y. So I'd have y equals 5 times x plus 1 all over 3 squared. And I can go ahead and find dy over dx by just taking the derivative. I'd have 10 times x plus 1 all over 3 to the first power times the derivative of x plus 1 over 3, which is just 1/3. And I would end up getting 10 times x plus 1 all over 9 as well. Let's look at example 4. Find the line tangent to the right-hand hyperbola branch defined parametrically by the equations x equals secant t, y equals tangent t, where t is between negative pi over 2 and pi over 2, at the point square root of 2, 1, where t is pi over 4. Well, first, we need to find the slope, which is the derivative of this. And since it's parametric, we know that dy over dx equals dy over dt divided by dx over dt. So this would just be the derivative of y. So the derivative of tangent t would be secant squared t divided by the derivative of secant t, which would be secant t tangent t. Then when I simplify this, my secants can cancel out, and I'd have secant t over tangent t. And then looking at this, to go through, you could put it in terms of sine and cosine. And I'd have 1 over cosine t times cosine t over sine t. So since tangent t is sine over cosine, I can multiply by the reciprocal, which is cosine t over sine t. Those cosines cancel out, and I get 1 over sine t, or cosecant t. So this is my formula for slope of the tangent line at any given point, but I need to find it specifically at pi over 4. So I need to find dy dx at t equals pi over 4. So this would be cosecant of pi over 4. And cosecant of pi over 4 equals square root of 2, which would be my m. So I have my point square root of 2. I have, well, my slope square root of 2, and my point square root of 2, 1. So it would just be y minus 1 equals square root of 2, x minus the square root of 2. And if you wanted to simplify this further, it would be y equals the square root of 2x minus 1. So let's go ahead and look at one more quick quiz. Which of the following give dy dx for the parametric curve x equals 3 sine t, y equals 2 cosine t? So after you go through and do this, hopefully you get the answer of C.